But welcome to the webinar. I'm your host, Kane Sims. I'm the founder of VUX World, and I am delighted to get into this webinar that we have today with Deepgram, presented by Deepgram. We're speaking to Adam Stipniewski, the CTO of Deepgram, and we're going to be getting into some, I would say, some pretty hot topics, actually. Can we turn on closed captions and subtitles? Very good question, Disha. I don't know whether Zoom has that built in. I do. Oh, yes, it does. There you go. Let's have a look. Copy. Oh, no, I need to do something with an API talking with this. I'm afraid that that it will not be possible to do closed captions, I'm afraid, Disha. But maybe that's something that we could use Deepgram for in the next webinar. That's probably something that we should do. Cool. So what we're going to do is we're going to kick off in a moment. I'm going to introduce Adam. Before we do kick off, though, a really quick kind of like housekeeping situation. If you do have questions, there's a few people already making use of the comments and the questions. Please do ask questions. Michael, yes, it will be recorded and you will be able to watch it later. There'll be a link sent to you in your email either tomorrow or Monday. So please do feel free to ask questions. We're going to be talking today about the irony of big tech and why the big tech companies that you may all use for speech recognition, or at least when you come to think of speech recognition, you might be thinking of Google and Microsoft, etc. We're going to be having a discussion today about why those companies actually don't always have the best solutions as you might think, why they don't actually innovate as quickly and as often or as frequently as you might think as well. And we're going to also get into some really practical conversations around your speech recognition solutions, whether you're using speech recognition for voice assistants to power your voice assistant on the front end, whether you're using it in your call center for transcribing calls for quality assurance and monitoring or compliance purposes, whether you're using it in your products for things like dictation capabilities or anything that you might have a need for speech recognition for. Adam will share with you today how to properly audit your current speech recognition system, some of the real kind of like qualities that you should be looking for when it comes to speech recognition, some of the reasons why those big tech companies don't always have really truly innovative solutions, what innovative solutions look like, and crucially, what is the business benefit and point of having speech recognition work more accurately, work quicker, and all of those kind of things. And so as we get through the conversation, do feel free to put questions in there and we'll get to them as often as we can. And so that's pretty much it. It will be recorded, as I've mentioned. Please do participate. Please do get your questions in there, and we'll do it. So let's kick off. Adam, welcome to the webinar. Glad to have you along.
Thank you so much, Kane. Happy to be here.
Yeah, likewise. So I feel as though I'm kind of, I've been working with Deepgram for quite a while. I read everything Deepgram publishes. I'm definitely a fan of Deepgram. I used Deepgram on a couple of projects in the past, and I'm getting my head around now speech recognition and all that kind of stuff. But it's one of those things, it's one of those areas where you think you're grasping it, and then all of a sudden you learn a bit more and you realize actually you just don't have a clue. Is it a real complex area of technology, or is it that once you've got the basics and principles, you can actually use that knowledge productively?
It's actually fairly complex, and it's like that for a number of ways. One of the biggest ones is just knowing how you're going to use it. You know, if all you want is to take an audio file, get a transcript, you can do that pretty straightforwardly. You know, pick any ASR vendor. You know, you might have different accuracies, but then you got to wonder, what are you going to do with that? Are you just providing a transcript and that's absolutely it? Or are you going to analyze it? In that case, you know, how do you spell things? If somebody says 123, do you want the numbers 1, 2, 3? Is your NLP processing pipeline expecting numerals? Are they going to be able to process words? And so there's this big conversation that starts to happen as you realize, holy cow, actually using speech recognition is more complex. And then there's all sorts of use cases around like, what sort of latencies do I need to power my business cases? You got to start thinking about where it really fits in.
Very interesting. This was billed essentially as the hooray for the independent innovators, Gaya is saying. Yes, indeed, absolutely. One of the things that we were teeing up this webinar for is, you know, you see stuff like Google I/O, you see Microsoft MS Build, you see Amazon, is it Rework, and all of these kind of conferences. And there's always new things put out there. There's always kind of like new either language models or updates to various speech recognition algorithms and whatnot. And I think that certainly in my perspective, from talking to a lot of brands that utilize this kind of technology, is that the big tech companies seem to be the kind of default companies when it comes to this kind of stuff. Or we've got, we need to, create a voice assistant. We already utilize some Google services. Let's just use the Google Cloud, speech to text. Maybe we've got, we're a Microsoft house, so we'll use Azure. And the kind of general vibe is that the companies with the budgets, the companies with the resources must have the best technology, the most reliable technology, the better performing technology, whereas that isn't strictly the case. I'm wondering whether you might be able to share with us some of the nuances when it comes specifically to speech recognition that maybe are different in terms of how Deepgram might work compared to how some of the big tech companies operate, and then what the impact of those differences is.
Sure. So it's definitely not the case that the big tech companies care that deeply about speech recognition. You think about companies like Microsoft, very big companies. They've been doing lots and lots of research into speech recognition for a very long time. But are they putting that in production? No, just last year they spent $16 billion to buy Nuance. Like, well, why did they have to buy Nuance if they've been putting all this research into it? Because it didn't come to production for them. It didn't solve their customers' needs. Or you can look at companies like Google. Is Google known for speech recognition? No, people will use it because it's Google. No one got fired for choosing Google, right? But at the end of the day, Google's an advertising company, right? That's where the bulk of the revenue comes from. And you can sell excess compute and things like GCP, but why would they offer speech recognition at all? Well, I think a good way to think about it is to say, well, why did Google ever create Chrome? Is it because they think that having the Google Chrome browser is going to make the world a better place? Are they now a browser company building browsers? No, none of that. They built Chrome so that Google would be your default search engine, so they could collect more data on you, so they can advertise to you more effectively. It's a similar play here with speech recognition. They're interested in collecting data on users so they can better advertise and profile them. Their core product, their core competencies aren't in speech recognition. These are just kind of ancillary ways to kind of collect more data, and if they stop doing it at all today, not going to affect their bottom line. If you really want a company who's going to continue to be innovative and push on the boundaries of what could possibly be done with speech, you want a company that's laser focused on speech. And that's what we do here at Deepgram. We're thinking just about speech. What can you do with it? And that's it. We're not trying to do it, not trying to guide it in any other way. Just thinking about speech. It's our lifeblood here.
It's interesting that, isn't it? Because I was having a conversation with somebody the other day who was talking about some of the large organizations, as you've just mentioned, that have large contracts with big companies, and they're deploying certain, cloud infrastructures and stuff like that. They then become the default provider when it comes to certain kind of AI capabilities. But it's almost like, call me cynical or not, and I don't know how whether you would kind of agree with this, but it seems to me that the cognitive services seem to be almost like a gateway drug into larger cloud deals, rather than actually, as you've mentioned, the core competency of the company. Correct me if I'm wrong, but that's kind of the way I read some of these things. I see Ford sign a big contract with Google. The headlines that we will read is that Google Assistant will be in all of Ford head units, but you look at certain other publications and you see actually that was just the icing on the cake, because what was really sold was a $2.5 billion cloud deal or whatever it is. So I don't know if I'm getting cynical in my relative age, but I don't know what your thoughts are on, because it does appear as though some of these cognitive services may well be gateway drugs to other things for some of these organizations.
You're absolutely right, 100%. Just like Google's an advertising company that can sell excess compute on GCP, now let's zoom into the GCP realm. Like, you want to sell companies on GCP, how do you sweeten the deal? You say things like, we'll throw in, discounted speech recognition. And okay, great. Now you use it, and now you start to get into it, and you start to get vendor lock-in. And now you're stuck on whatever update, release schedule Google has in mind. And you're not going to get a heavy focus on quality of ASR. You're right that you do see publications or headlines here and there about hey, Amazon reInvent, and they're talking about their, new speech stuff, or Google, and they'll talk about the new speech stuff. But really, nothing's changed. The underlying tech isn't really that different that they're using. And those changes are, in other words, kind of small things. They're just something to put a headline out. But is your speech recognition getting that much better? Is it getting that much faster, more accurate? Is it covering more languages? Not really. It's not really changing, because at the end of the day, it becomes just not only a means to collecting data, in the case of Google, but also just sweetening the deal for GCP. Or that's the same for like AWS, the ecosystem. You use AWS Transcribe to kind of sweeten the deal on being in the AWS ecosystem. And if you are worried about vendor lock-in, and you generally should be, then you should be looking elsewhere for your speech recognition. It's not going to come, if you're looking in the right place, it's not going to come at a higher cost. You'll be able to find cheaper and better solutions elsewhere.
Playing kind of, I suppose, devil's advocate, or being given that, there's nobody from Google here, one might say, well, if they don't innovate, I don't know if you can hear Winston going crazy there. I specifically told him to keep it down. One might say that once you reach a point, that good enough might be good enough. So when it comes to speech recognition, let's say in Google, Microsoft's case, whatever it might be, we've done something, we've created some speech recognition models, they're kind of being used, they're being deployed. Is good enough good enough? When you say that they haven't innovated beyond that, they don't regularly do updates, what kind of stuff happens in that kind of innovation? And what constitutes kind of improvement, so to speak? Like, is good enough ever good enough, or is this something that is just constantly iterating and constantly moving? And I wonder if you can shed some light on that.
Yeah, I mean, the other way that I hear that said sometimes is that people will say that speech recognition is a solved problem. And it's just not. There's so much room for growth and improvement. And it comes in two flavors. There's the technical side and there's the product side. From the technical side, you're thinking about things like, how much does it cost? How fast is it? Does it scale? How accurate is it? That sort of thing. Just kind of like, these are the necessities to make a business case. And honestly, if you're above some threshold there, you could probably compete in the world. Good enough is good enough to some degree. That's true. Now, if you want to cut costs, if being 5% more accurate, 10% or 20% more accurate is important to you, you still have a lot of room to select in there. But there is a good enough sense. On the product side, it's a lot different. Over there, you're thinking about things like features, like do you support diarization? Do you support multi-channel audio? What languages do you support? What dialects do you train and customize models? What SDKs do you have? How do we integrate with you? How easy is it? What support do you have? So all the product-related features are over on this other side. And if people hyper-focus on the technical side, they're going to find differentiators. But if you kind of blur the lines, you're not going to really notice them. You're not going to be paying attention because good enough is good enough. But then you look on the other side and you're like, how do I make this a really compelling experience? You really need people who are thinking about building speech experiences. Those are the experts who are going to help you get your voice experience, your voice product to the next level. You want their input. You want their expertise. You want APIs and SDKs that are built for your use cases. And that's where companies like Deepgram come in. We try to make that incredibly easy. The time to get your first transcript ever should be like that, so fast. We want to be able to provide all the resources you need to make that easy. You're not going to get that at other providers. And I would say on top of that, even if you want to ignore that and say, cost is the best thing, or latency is the best thing, or X is the best thing, try Deepgram. I bet we're going to beat their latencies. I bet you we're going to beat their costs. I bet you we're going to beat their accuracy. So looking at companies that really deeply care about this, you're going to see some pretty drastic differentiators start to come out.
I didn't really think about the product side. I'd love to dig into some of that in a moment. And we've got a question from Rahaf, which I will get to in a moment. But you mentioned there speed. You alluded to speed. And so I think now is a good time, a better time than ever, to run our first poll of the evening or morning, probably for most of you. So the question that I'm going to ask is, how long do you think it takes to process an hour's worth of audio for speech recognition? So let's say that at the end of this recording, we're just going to take the audio file. This webinar is going to be about an hour long. If we take this audio file, transcribe it into text, how long do you think it will take to transcribe that audio into text, to run a speech recognition process on this audio. Cast your votes now, and Adam, I'm sure will shed some light on the actual realities of that. So the vote's coming in now. As you were saying there, you were talking about the service side, the product side, and I never really thought about that before, because as I've mentioned, I've kind of worked with speech recognition systems a little bit in the past, well, quite a bit in the past actually, but always from afar, as in we need some speech recognition for this product. And so you're always using the APIs and stuff like that. You're never really kind of behind the scenes, and often, what you get given is what it is, kind of thing. I know we'll get into a little bit later on the importance of doing things like training customized models and all that kind of stuff, because I definitely am a huge evangelist for that. But I think that the other thing with using I would say maybe some of the big tech providers for certain capabilities is that lack of support, isn't it? So when people are creating voice assistants, when people have got now cloud call centers and they want to start transcribing calls and all these different kind of use cases, if you hit a roadblock, if you hit a problem, it's almost impossible to actually get it resolved, because who do you talk to about it? So I wonder what are some of the things from the support side, from the product side, what are some of the regular things that people need support with when it comes to utilizing speech recognition in general?
Sure. So they come in a number of flavors. I mean, some of them are just help with documentation. It's like, I'm trying to do this, and I tried this, and I'm not getting what I need. And usually, 90% of the time, it's just, hey, this is where you need. This is what you want to do. Just simple answers. But you know what? People are smart. Giving them simple answers helps. They're trying here. You're working it through. Just be there for them. So it can be very, very simple. Sometimes it's more complex. That requires a little bit of brainstorming by both sides. Like, hey, I'm trying to build a conversational AI system, and I want the user to say yes or no. But the users kept saying things like yes, yeah, and I don't know, how do I capture that? Well, you want to have what you were trying to capture. If you start talking to the providers, is you're trying to capture semantic information. You don't care that it's yes, yep, yeah, You care they've made an affirmative of some type. And so, if you could talk to your provider, your speech provider, they can point that out to you and say, well, you could try to just build a grammar, but that's kind of an old school way to do it. What you really want is like semantic tagging, and here's how you do it. And this is the features you turn on for that. This is how you would plug it into your downstream system. So it's more advanced stuff, but sometimes you just don't know what you don't know. Your speech provider has been there and done that, and it's to think about this, and they'll guide you through that. And then there's a third case of things that just don't exist now. Like, hey, I'm trying to build whatever it is, and I need it to act like this. And the speech providers can be like, I never thought about that. Or maybe they did think about that, and they just haven't had a chance to focus on it yet. But the point is that there are things that just haven't been built yet. And that's okay. This is where innovation comes from. And you think that you're going to be sitting down and talking with Google or Amazon and saying, yeah, I think you guys need to build that. And they're going to say, that's cute. No, if you talk to a company like Deepgram, you're like, you know what, that's a really good point. And I bet there's other people going to use that, or that's been in our product roadmap for next year. Let's move it to next quarter, because you know what? We have a really good, now we can build a partnership where we can try building it for you. You can tell us how it works. We can use it to improve our product. You get a better and a better experience, and we solve the problem together. And these are things that you will get if you are working with a company that's just incredibly focused on the speech experience. Kind of another way you can cast that and think about that is look at other great product companies, tech product companies that are really build infrastructure. Think about Stripe. Think about Twilio. Were they the very first movers in their industry? No. Why'd they come out ahead? Because their product experience was so much better. They were focusing on the developers. They were focusing on the resources. They were trying to build things that developers needed. And you might not think of yourself, everybody listening, you might not think of yourself as a developer, but if you're integrating with other systems, and that includes speech systems, there is a developer somewhere in that pipe. And you're going to be relying on their ability to integrate easily in order to remove all the edge cases that might come out in your downstream processing. Do you want, to build something that a month from now, there's some weird edge case in the Google API, for example, that just crushes your product? Or do you want something that is built to make that experience just trivial, easy, clean to understand, and has support when it comes to it? That's what you want. You want that sort of thing. That's why Twilio and Stripe won. That's why Deepgram's going to win the speech game.
very interesting. Yeah, the poll is done. So we'll say we had around 80% of the attendees were voting on that. We've got 14% of the vote. So the question was, how long does it take speech recognition to process an hour worth of audio, such as a webinar like this? We have 14% of people said it was over an hour. Would certainly take over an hour if I was going to do it myself manually. 30 to 60 minutes, 4% of people think it takes that long. 15 to 30 minutes, 7% of people. Most people thought it takes between 1 minute and 15 minutes. Half of the people that voted thought it takes 1 minute to 15 minutes. And 25% of people actually said less than 1 minute, which I think sounds very low. But Adam, put us out of our misery. How long does it actually take to transcribe an hour's worth of speech?
Sure. It depends on the technology you use and what the company that's providing it is focusing on. For most modern speech providers, this includes things like Google or Amazon. If you don't believe me, go try it. When you get the link on Monday or tomorrow, send it off to Google or Amazon. It usually takes about 30 to 60 minutes to process 60 minutes of audio. That's the typical SLAs they have in place, and that's typically what you actually observe. People who have really thought about speech and speed will usually try to optimize pieces of their pipeline. And Kane, I'm sure you and I are going to talk about this a little later, but what are the differences between Deepgram and other companies? Like, what does the tech look like? But most people who use traditional tech can speed it up, and then you'll typically see things in the a 4x, 4 to 10x speed up. So that means the hour of audio is going to take somewhere in the 6 to 15 minute range. That's considered quite fast. I don't know of any providers other than Deepgram who are going to provide you that hour-long transcript in less than a minute. Deepgram can typically provide it in a few seconds. And that's because we've rebuilt the entire stack, re-envisioned it from the ground up. So yeah, give it a try. Play with the vendors. It's really surprising. And not only is it surprising just to think about, wow, 36 minutes, but if you step back for a moment and say to yourself, what does that mean for me? If all you're doing is transcribing a podcast every week, it probably doesn't matter. It probably doesn't even matter if it's a day later. But if you're trying to do business analytics, you're trying to do compliance, you're trying to track, like, what are my customers talking about? Which competitors are coming up? If you want as close to real time as possible, then what does 30 to 60 minute delays mean for you? It could be really bad. It's going to put in, if you have a pipeline or a buffer that's queuing up, it's going to probably get worse over time. There are use cases that you unlock when you have transcription happening in fractions of a minute, a few seconds. It's incredible. There's so much more you can do when speech recognition suddenly feels instantaneous. You can build new things that you haven't envisioned before.
I can't even believe that it can take less than a minute to process an hour's worth of audio. I've got some questions coming through. I will get to these questions in a moment, I promise. And thank you. Keep them coming. If you've got any queries about this, keep them coming in the questions. We will get to them. But I don't even get that. Like, what is it that allows you to process an hour's worth of audio in less than a minute? Like, is it just speeding up the audio tremendously? Like, really? Because then obviously you're going to end up with, if I was just to speed up an hour's worth of speech and compress that to a minute and then press play, it would just sound like a total jumbled up mess. So in my mind, it seems as though it can't be as simple as just squashing the audio and speeding it up. Like, there must be something else going on. Like, what kind of, I don't have to give away the secret sauce, but like, what is it that's the difference between being able to do that in under a minute versus the traditional way, I suppose, which is, as you said, over half an hour? Like, what are some of the component parts that enable this stuff to happen?
Sure. So the way that people, companies, industries, research science has thought about speech recognition for about the past 30 years has been in a fairly knowledge engineered fashion. This is very common. Knowledge engineering is not a bad idea. It's a great way to just kind of decompose and understand your problem from the ground up. A lot of AI has been traditionally knowledge engineered. But what that means is, you think about, like, okay, what are the steps involved and how do I model each of those steps? How do I model all that decision-making process? Well, in the case of speech recognition, usually audio comes in and there's a model that takes out the noise. Then it goes to a phoneme model. Now, a phoneme model predicts the small snippets and parts of words. K, b, n, f, all the little pieces that words are made out of. That phoneme sequence then goes to a word model that takes that and says, oh, that combination of that series of phonemes right there, that could be this word. I guess it could also be this other word. That's true. Or maybe it's these two words. You have a word model that kind of starts to stitch things together into possible word candidates. And then that feeds into a language model, which says, okay, this is the most likely thing people would say. They say that word and then that word down there, and these are sentences that come out. That's how it's traditionally done, and it breaks the problem into like small, easy to understand as a human pieces. And then you have these four models or so, and they're typically implemented with simple machine learning algorithms like hidden Markov models or finite state transducers. They're fairly simple models, build, simple to train. You put it all together, and it just turns out that this whole pipeline takes a long time to get through. It's also really hard to train. And you can kind of imagine that, like, what if you retrain the phoneme model, make it a little bit better? Well, now its outputs are about different, right? It's improved, so it's producing different outputs. But now all the other models downstream are receiving different inputs they haven't been necessarily trained or optimized for. So you have this iterative training problem all the way down. And frankly, the little models inside there are just not really well adapted to dealing with the complexities of speech. They're typically too simple, so you can't model how big speech is. And at the end of the day, they are slow. Back in the 30 years ago, back in the 90s, you would typically have single-threaded, single-core systems, and very little has changed in a lot of these traditional pipelines. So Deepgram thought, okay, if it takes 30 to 60 minutes to process an hour of audio, and we're looking at a world that is increasingly moving over toward compelling voice experiences as a primary or at least a major component of human-machine interaction, then that sort of scale is never going to cut it. You're never going to get anywhere with it. So what do? Well, what do humans do? This is a great way to just think about a lot of problems. What do humans do? And I don't mean from a knowledge engineered way, just physically. What happens? Audio goes in through the ear, and then the brain just produces an output, and you know it. You know it has been said, and it's it. It's an end-to-end model. At one end, in comes the audio, and at the other end, you have a thought. Speech is a way of programming people's brains to produce chemicals. And what if we did that? What if we threw out all this idea of this traditional stuff, this pipeline, everything? What if we tried to build an end-to-end model that had audio come in? It was a single model, and it just simply produced the words and sentences and utterances people have. So we tried that. We're like, let's build a single model. This will be much easier to train now because there's only one model. Let's try using deep learning for this instead of these smaller models. Well, we did. We used a deep learning architecture in there, and those are very large, almost by definition. And so if something large, you can start to model really complex things like speech. So it's perfect in the speech space. And then let's accelerate it onto GPUs as well. And so we were using accelerated hardware to be able to not only train, but also infer on. And you put this all together, and now that it's easy to train, it doesn't have this artificial accuracy cap due to small models. And boy, is it fast. I mean, it's not even just the GPUs that make it fast. That's a plus. But just putting all these all together in a really effective inference engine means that you can now suddenly get the hour of audio in a few seconds.
Wow, that's interesting. I never thought about adding the whole GPU situation in there for faster processing and all that kind of stuff. Is there any or many other companies that have this kind of approach? It sounds as though Deepgram arrived at this approach kind of partially organically, but then also because of, I'm assuming, lack of satisfaction with your experience of existing ways of doing it, which is where most innovation comes from, isn't it? There's a process that happens here. It's not a very good process. We can improve that. Let's go and do better. So is this a common approach, or is this something that is like unique to Deepgram?
It's an approach that's starting to gain traction. People have experimented and thought about, models like this, architectures like this for a little less than 10 years for all practical purposes. But very few have tried to put it into production, and no one has tried it at scale. until Deepgram did. And now other people are starting to build pieces, build end-to-end systems. So it's starting to become more popular to do this sort of thing. And you also have companies that take that traditional pipeline of form model and try to improve pieces of it. Okay, we'll take the phony model and we'll accelerate on GPU, or we'll take the word model and replace it with a deep learning implementation. So you have people that are starting to explore and experiment with other kinds of architectures. And this is where you start to get companies that are in that 6 to 15 minute range, that sort of speed up. But for an hour of audio, that is. But nobody's just kind of focused so hard on the problem as Deepgram has to get it down. But yeah, you do start to see it, and I expect that going forward, more and more people are going to try things this way. I mean, if you sit back and look at the history of the universe and like, why are we here? It's because, well, deep learning, large neural networks have been around as a concept for a little while. But we just haven't had the data, right? If you have a lot of parameters, you need a lot of data to constrain them, or the compute. Because the moment you have a lot of data, you need to train for a long time. We haven't had the data or the compute until really the last 20 years. Back in the 2000s, you finally have high-speed internet in enough places in the world that you can start to collaborate really, really well to build large data sets. And it wasn't until like the early 2010s with CUDA and NVIDIA's new graphics cards that GPU processing was really available. And so you put those things together, and like around 2012, something like, wow, deep learning is actually a possibility and not just a thought. And what happens? What do people do? They immediately jump onto image recognition. That makes a lot of sense, because if I show you a picture, I say, what's in this picture? You have 5 seconds to look at it, and then I take it away. Oh, you can go on and on. You can tell me, oh, there's a dog on the beach. There's a sunny day. This is the background on the water. He's got a blue frisbee in his mouth. You can go on and on and on, because there's so much information so compactly. If I tell you, here's one of Kane's podcasts from webinars from last week, and go listen to it for 5 seconds and tell me what it's about. You have no hope, right? Because audio is very slow. You can't listen to audio faster than it can be spoken, and it can only be spoken in real time. It takes a person 60 minutes to speak for 60 minutes. Now, if you think about what's easy, it's image recognition, because it's so compact. And so people jump in that, and that's where you suddenly see these end-to-end models, deep learning empowered models, just dominate the image recognition field. And basically, Deepgram did the same thing. But we decided to tackle the hard problem, tackle the speech problem, and see what that does. And that's taken off. And I expect, just like with image recognition, these end-to-end models are going to continue to dominate the industry for the foreseeable future.
Absolutely. So I'm gonna do another poll here. I just realized the quote from Andrew there, which is something we mentioned a bit earlier on, which is cognitive services are a gateway drug. Quote of the year. And I think another one is another quote that I liked, which is what you've just said, which is that image recognition. I mean, if you read the headlines, if you follow the AI broadly speaking in all different areas, image recognition and getting image recognition to be more accurate is kind of like some people are like working really hard on it. And I like the way that you just threw in there that you just had to tackle the actual hard problem, which is speech recognition, because it just kind of, if image recognition is easy, then speech recognition must be pretty challenging. So I'm going to throw another poll out here, which is asking really simply, what's your level of experience when it comes to using speech recognition applications? So have you, for example, if you've never done anything before at all with speech recognition, you're just here because you're interested in it, I'd probably say that you're a beginner. If maybe you've used it, maybe you've used some of these services we're talking about to build like a voice assistant, or maybe you've kind of been working in a call center and you've used it for transcribing calls and like that, probably intermediate. I would say if you've been using it for a long period of time and you've done things like we're going to talk about in a moment, like, retrained speech recognition models for certain use cases and stuff like that, I would say that you're advanced. And so, I'll give you a couple of minutes to vote on that. At the moment, it looks like everyone's kind of split between the whole thing. Beginner, intermediate, advanced is more or less a third. But do keep going. And the reason why I wanted to do this is because, we've spoken. I've spoken to people at Deepgram quite a lot over the last 12 months, 18 months since we've been kind of working together. And it's really interesting. Every time I speak to somebody at Deepgram, every time we have a conversation, I speak to Scott, I speak to you, it kind of, I feel as though I learn a bit more. And I also end up becoming a lot more kind of evangelical about some of these things, like retraining speech recognition models for a specific use case, regardless of what call center you have, what industry you're in, or regardless of what voice assistant you're creating for whatever use case you've got, chances are you're going to have kind of customers, jargon, terminology that is unique to your industry, your company, your customer type, the geography of your customer, the accent they might use, the slang they might use. There's a whole range of different things that you need to be able to cater for, all related to your specific application of speech recognition, that sometimes the kind of, like, I suppose, general or off-the-shelf models might not necessarily fare well with, unless perhaps you can correct me if I'm wrong. So I just wonder whether you can shed some light on, you know, when a general model is good, when should you look to kind of, you know, retrain or further train your models? And then after that, we can maybe get into some of the specifics around, like, what's the process of doing that? Because I know there's a few people over there at Deepgram which, you know, kind of suggest that, like, every speech recognition model ought to be tuned to some degree to your use case. So I wonder whether you can kind of, first of all, maybe start with some of the differences between, like, the general models, for want of a better word, and the you know, I suppose, what is it, retrained models, should we say?
Sure. So, I mean, general models are obviously great entry points. You want to get started, you want to see what it's like, you want to, you know, dip your foot in the water. They're great places to start. And I would highly recommend everybody kind of start there. You know, pick one that makes sense. You know, Deepgram has several, like just a general model. We have phone call models. We have meetings models. You know, pick one that kind of makes sense at a very high level. But just try it. And the question to ask, you know, do you need something more than a general model? It's going to boil down to, well, does it solve your business problem or not? And reasons that people ask custom models are twofold. First is because they have an unrealistic expectation of what speech recognition can do. You'll have people who ask, hey, we need our speech recognition to be 98% accurate all the time. And that is not possible with the state of technology today. It can't be done. In fact, humans themselves, you have a human sit down and type things, they're going and transcribe by hand, they're going to usually have 96 to 98% accuracy already. So asking for something more than that just doesn't make sense. It's kind of a meaningless question unless you have a very restricted domain. So if you have an unrealistic expectation, then people just kind of always want better and better and better. But that's also kind of a bad way to think about it. What you really should be thinking about is the second point, which is, does it solve the business problem? Does whatever you're trying to do with speech recognition solve the problem that you're out to solve? People aren't usually getting speech recognition done because they just want the transcript. They want to do something with it. They want to read it. They want to process it. They want to analyze it. They want to store it for compliance purposes. Who knows? But does it solve the problem? And that's where you really need to think very hard about the problem you're trying to solve and the product you're trying to build. This is where it's also very nice to be able to have open communication with a support team from your speech provider. So they can help you understand how to help, you know, design that product and what expectations to have for how it should work. And if you can identify good reasons that you need to specialize the model, it's a great reason to come and say, hey, I need to have the accuracy this much better. Like, this is the threshold at which something downstream breaks. Or, hey, it doesn't really do a good job on my domain-specific keywords. How do I improve that? Or, hey, my target demographic, you know, accents or whatever, it doesn't work as well on it. I need to push the accuracy up. And at some point, it usually boils down to some type of accuracy. And those are great reasons to start to specialize. And then you talk to your provider, in this case Deepgram, and you just say, hey, I want to build a custom model. The company like Deepgram will take that data and we will send it to the research team to produce a custom model. Sometimes that involves labeling. It usually involves labeling by humans, but other techniques you can use as well. And then you get a model that comes out and you can go deploy. And now you're simply making different model requests. And usually you'll see if you ask for a custom model, you'll usually see pretty drastic improvements in those domains where, you know, you were seeing failure modes. The more that you can show these models examples of where it has done poorly in the past, the better that it can improve itself. Now, everybody, of course, would like for you not to have to specialize models. Nobody likes the idea that I have to pick one of 20 models. But there's hope for being able to improve that. It's just that all of technology and all of human history is incremental, right? Nobody likes telephone lines all over the place. But if we had never allowed telephone lines to exist, we would never have gotten here at least as quick as we did, right? Telephone lines are a necessary evil to get us to the next state in our technology. Similarly, you know, it's not really clear how we would have speech providers in general, not just Deepgram, everybody. There's an open question about how do you just have one model to rule them all? And it's hard. It's a very hard problem. But you could start. There are ways, there are paths forward to kind of start to unify that. Really simple examples are language detection. I have audio, but I don't know what language it's in. Can you still find the right model and transcribe it? And the answer is yeah, we can do that. Some other providers are capable of doing that. And that's a great example of you actually have specialized models. Most people have an English model, a German model, a French model. They don't have a model which does English, German, and French. They have a number of models, and they're trying to select out which one is necessary in order to get you the best accuracy, which is in this case language detection. So there's examples of where you can start to unify that, at least at the API level. And there's hope of how you could also unify it in the model itself. You do have a single model that can speak English, German, and French all together. And so there's different ways you can approach this. And technology is marching toward a world in which this will be easier and less necessary. But in the meantime, having the ability to specialize models is really, really important because your business needs need to be satisfied now, not 5 years from now.
Really good, really good. So when they did the poll there, we had about, as I said, it was about a third of each: third beginner, third intermediate, third advanced. Advanced is actually a little bit more now. It's looking at around about 40%. So for those people who are in that 40%, who are pretty advanced, those are people who have been working with speech recognition, either speech recognition APIs or maybe even behind the APIs, perhaps in some way, shape, or form. What, in your experience, given that you've basically, everything you've been talking about, you've kind of built, I don't know whether everyone who is in that kind of advanced category has perhaps kind of done the same. What are some of the things that even those people who have been working with speech recognition for quite a while, what are some of the things that you think they may face as a challenge, or some of the things that maybe gaps that they might have based on where things are at now, based on the kind of things that you've just been explaining around, general models versus customized models and all kinds of stuff? What kind of gaps or challenges do you think those kind of advanced users of speech recognition would be facing at the moment?
Yeah, I would say they kind of fall into two categories. Are you trying to use speech recognition, or are you trying to build and hack at existing speech recognition systems? If you're trying to build and hack, the biggest problems you're going to run into are data problems. There's not that much labeled audio data in the world. It's very different than the image space. We have things like ImageNet and the huge databases of labeled images. You're going to run into data problems, and that's typically the biggest thing that's going to hold you back from getting the accuracy you need. And most companies that I have seen try to build in-house speech recognition ultimately fail for that reason, that they don't get enough data to really get the accuracy where they need it to be, and they end up ultimately scrapping the project. If they're lucky, they'll scrap it in 3 months in. If they're unlucky, it'll be 3 to 5 years later, and with a massive debt to pay, internal debt to pay on that. For people who are using speech recognition systems, I think that the biggest struggles that I tend to see are struggles about clearly defining what the problem is. And usually, your business problem. I absolutely trust you as users of the systems to know what you're trying to solve. But you have to talk to the speech providers because they may not quite understand, if you haven't spoken to them before, what you are actually trying to do. And that's where I talk about this impedance mismatch, I call it, an expectation mismatch. And I think about the conversational AI systems where you really want semantic information like affirmatives and negatives rather than lexical information like yes, yeah, knowing that that's what you want and telling the speech providers that's what you want is important, because it's very common for even conversational AI companies to say, I need to get yes, yep, right all the time. And the answer is actually you don't. Let's understand why. And that's true for the speech providers who are like, oh, you need yes, yep, okay, let's look what's on that. Let's build a custom model for that. So they didn't realize that there's a communication gap here about what they actually need to build. And so talk with the speech providers, help them and let them help you understand what you want to build for together, because this impedance mismatch is real. Remember that you're talking about an ASR company, for example. You can build other things, NLP, NLU on top of that. But when you're looking at speech recognition in isolation, it's meant to be kind of general. It's meant to serve a bunch of different use cases. But everybody who builds on it is having a more and more specialized use case. And so it's really important that you give speech writers the opportunity to talk with you, to open dialogue about what you're trying to do, so they can help guide you, not just guide you, but even internally guide their product in the direction you need. So I would say that's a big thing. Have open dialogue about what you want to do and how you can best achieve it. And the second thing is always be aware of what those good enough constraints are. Right now, the market isn't as good as it has been, and it's probably going to be rough for a while. Are costs something that are important to you? Would you be willing to switch providers if the cost was a tenth of what you're paying now? Good question. Would you be willing to switch providers if the accuracy was, 20% better than it is now? What would you be willing to switch if speed was 10 times faster than what it is now? What could you build as a consumer of speech if things were 10 times as fast? Think big. And there's like all these sorts of things that, again, speech providers can help you navigate if you give them that opportunity to dialogue. But these are good things to be thinking about, and these are common problems that people run into.
Very good, very good. I'm going to get to some questions because we've got 15 minutes left and we do have quite a few questions here. So if I don't get a chance to get through them all, apologies. Maybe we can follow up in an email afterwards or so. But first question is, maybe this kind of taps into some of the stuff we've been talking about here, but it's a question from Rahaf, which is, what's your take on the current state of dysarthric speech recognition, as in recognizing the speech of people with speech disorders, speech impediments, things like that? What's the current kind of state of play as far as that's concerned?
I would say that it's not great. Honestly, it's not great. And it kind of unsurprisingly comes back to a data problem. It's that you want to train models that can do really well, you need lots of data. But the moment you start collecting data on people, especially targeted demographics, you start to run into a lot of privacy and regulatory concerns. And that can make it even harder for speech providers to get a hold of that data and help you. And so there's real troubles and real obstacles to overcome to be able to get to that point where speech providers are even capable of trying to help with that. But it all comes down to a data problem. If that's an important domain to you and you can think of ways to gather that data, talk to your speech provider. They'd probably be happy to work with you on that. Companies like Deepgram would be happy to work, especially on building these kind of specialized models for these really important domains that really aren't being serviced well. Help us help you, help us brainstorm together how we can find the data, how we can get the data, and how we can build the models that don't exist right now.
It's really interesting because did you ever see the company called Voice It? Did you ever come across them or not?
Yep.
Voice It, yeah. So they were doing something in this regard, and it was all about exactly that, which was kind of like voice recognition for those with speech impediments. The problem I found with it was that, and don't get me wrong, I think the capability is fantastic, but every individual has to train the system based on their specific speech impediment or speech disorder, and so it ended up being not quite speech recognition. It was almost like matching audible sounds to actions that you configure in their app. And so it's kind of like almost there, but it didn't really feel to me as if it was like actually speech recognition. It wasn't speech to text, so to speak, as we've been talking about. It was more kind of like, this is the sound that this person makes, and when they make this sound, it means turn the lights on or something like that. Does that make sense? Is that kind of what's going on there, or is there other ways?
Yeah, I mean, that's exactly right. And, that's another example of a data problem. Why are users being forced to train the model and improve the model? Because the company that's providing it doesn't have the data for it. They need the user to provide the data and create the data. And that's not necessarily a bad thing. Helping people even when there's, issues to overcome like that or inconveniences like training it can still be a great thing. This is, again, like telephones. There are necessary steps. The technology is not there to immediately help. Data is not there already pre-existing immediately help. But what can we do in the meanwhile? What happens when we kind of loosen some of those constraints, or tighten them rather? But meanwhile, yeah, it's just another example of a big data problem that needs to be overcome.
There's a good question here, which kind of harks back a little bit to the conversation that we had at the beginning around big tech and stuff like that, which is from Moje, which is it a correct assumption that Deepgram's ASR matures slower than Google's ASR and other big tech providers due to perhaps lower volume and a lower number of customers as perhaps the big cloud providers may have? Do you think is that kind of the case or not? I wonder if you can shed some light on what that might look like.
Sure. I don't think that's the case at all. I think it's typically flipped. The people whose entire livelihood depends on being able to push the boundaries of what's next, of what can be done, of how fast you get, how accurate you can get it, what features you can include. These are the people who are really making very rapid and iterative changes and improvements to everything. If we didn't, somebody else would, and you know, whoever was moving slowest would die. As it is now, Google and others typically move fairly slowly, and you can quantify that. You can look at how has their latency improved over time, how have the errors to their servers improved over time, how has the number of languages they support over time, how has time to transcript, you know, that the turnaround time, an hour, you know, 30, 60 minutes for an hour of audio, how has that improved over time? You see that it's fairly flat. Nothing's really changing. They're not really pushing on it. You will often see a lot of headlines around it. That's absolutely true. You saw a lot of headlines from Microsoft Research, and then they buy Nuance, right? Why? If they've had all this research going on. And so, you know, the headlines can be deceptive and paint a different picture than what's real, but the actual service that's being offered typically from large companies doesn't move very fast. They're not incentivized to. You know, even if people stopped using it, they would probably still provide it. You know, nothing's changing. If some of these big companies were to suddenly say, everything's free except speech recognition, they're going to go out of business because they are not, in fact, prepared to actually put the time and investment into improving these things. So, yeah, long story short, you tend to see more rapid improvements and more rapid innovation from the small companies who are finding every possible way to eke out advantages here. It's important. It's the only reason they're in business, because they can do it better.
Yeah, you certainly don't have the red tape and bureaucracy and levels of approvals and can we try this and all that kind of stuff. It's and that's where innovation comes from again, isn't it? I mean, you mentioned earlier on the difference between some of the traditional speech recognition models versus the deep learning approach. And when I just think about the how slow big companies move, even innovative companies like the big 5 tech companies, still internally, they're so big, there's so much bureaucracy, and moving things actually takes a long time. So I think you're right that a nimble organization with the autonomy to move into problem areas that they think is a priority can do it far quicker. And if they're dedicated to it because that's what they do, then surely they're going to put more passion, more effort, more kind of time, whatever it takes to kind of make it happens, doesn't it? We've got a couple of questions left. I know we're almost up on time, so we're going to do the next kind of like almost like a rapid fire style, not entirely rapid fire, but you know, we'll try and get through. There's another 5 or so questions here. So and apologies, a couple of them have come from anonymous attendees, so I can't give you a shout out. But one question is, we've spoke a lot about speed, and we've spoke about taking an hour's worth of audio, transcribing that in a matter of seconds. Is there a limit with the Deepgram APIs as to how long it can transcribe something for? Like, for example, if we were just going to run this webinar for the next, I don't know, 48 hours and just do a marathon with it, is there, if we were going to continue like that, is there a point in time at which it will break or stop, or is there a time limit on how long this thing can recognize and transcribe real-time audio?
In the case of real-time audio where you want to stream, there's no fundamental limit. We have some technical limits in place just so we can make sure that we have conversations with people before we, you know, they really are sending us 24-hour streams. Honestly, people have sent us 24-hour streams, and most of it's silent because they've dialed into a system, a voicemail system, and then just sat there because the other end didn't hang up. And it's like, okay, you have a product problem, we want to help you detect it, but there's nothing at all technologically that stops us from extending that indefinitely.
Nice. Is there a metric to measure the accuracy of speech recognition or recognized audio, like a confidence score? Word error rate, I'm assuming, is the one, is it, or is there other ways of measuring? If that is, what is that, and is there other ways of measuring the accuracy?
Yeah, the most common one that people look at is word error rate, which is the number of insertions, substitutions, and deletions that have happened between the transcript and the ground truth, divided by the total number of words. So, in other words, a perfectly accurate transcript has a word error rate of 0, but it's unbounded. It can be number 1 means every single word was wrong, but you can have 10, which means every word was wrong and you inserted 10 times as many words as necessary. So word error rate is the most common one. You want to get it as close to 0 as you can.
Cool. Do you have language, you alluded to this, do you have language detection based on the incoming speech? So someone starts talking, it can detect the language and transcribe immediately.
Yep, we do.
Cool. That was rapid fire. What about things like auto punctuation? I know that you've got models that do things like transcribe meetings and all that kind of stuff. Meetings and conversations like this that are long form can be a bit long-winded. People don't speak as they would write. Do you do things like punctuation, question marks, full stops, commas, that kind of stuff?
We do. All of our models can be fully punctuated.
Nice. Cool. What protocol do you use for streaming? Is it something along the lines of gRPC, sockets, etc.?
We use WebSockets, which are very similar technology to gRPC, but a little more widely supported.
Cool. And final question, I'm going to extend this a little bit more broadly. We do have another question, actually. We've got two more come through. So how does Deepgram compare to something like SoundHound's ASR, or as I said, we can extend that to Nuance, to Google, to Amazon? Like, broadly speaking, how does it compare?
Sure. So I would say that if you look across, the first thing, the most important thing you should do is try it with your audio, because it doesn't matter what everybody else, what numbers anybody produces. It matters about whether or not it can solve your problems, accurate enough for your problems. How do these compare with your problem? And the reason I say that is because it's very common for providers to quote numbers that are based on research or academic or standardized data sets, which are very easy to game and tend to be very clean audio and not really representative of real world business audio. It's also what people will very commonly do is, oh, I need to submit a file to test this. I'll just go get the lady Miley Cyrus video from YouTube and just send it up. It's like, wait. If you're transcribing Miley Cyrus music videos, this is great, but you're probably not. So please don't do that. You have to test it on your own. So I'll caveat everything with that. You have to test it on your own. Deepgram does not do any academic data tests. We do not do it out of principle, because we believe it is meaningless when you're trying to really solve business problems. So we are always benchmarked on our customers' data. And in that case, what we tend to find is that we tend to find that we fall, I want to argue and I want to say most accurate, but again, it always depends on your audio. Generally, we are one of the most accurate transcription vendors you can get. Amazon is quite good. The other vendors tend to fall off pretty quickly from there. Typical word error rate scores from modern vendors is in the 75 to 85% accurate. So about every fourth or fifth word is wrong. There's an error rate of 15 to 25%.
Yeah, and I suppose if you're transcribing something like calls and stuff, that might not be, I mean, you obviously want it as accurately as you can do, but somebody reading a sentence might kind of be able to fill in gaps, but it takes a lot of human processing to do that. But when you're working with something like conversational AI, you can't really have that, because it means that every fifth word you're sending into your NLU is complete rubbish, which means that the whole thing can fall down, basically. So I would definitely say that the higher the accuracy, the better. One question we have is, you mentioned labeling and that the data labeling mostly being done by human labelers. The question is, what's the best alternatives to human labeling? I would probably also say, is there an alternative to human labeling?
There are alternatives. By far, hands down, the best thing you could do is to have human labeled data. Deepgram has its own data labeling operation. So if you want to work with Deepgram to create custom models, just come to us. We can do all the labeling for you. If you don't have labels, there are some techniques that work. Sometimes text to speech works. It's a difficult, messy subject. It really depends on your domain. Deepgram also has research techniques for improving models without labels at all, but the improvements are all small compared to the improvements you get from human labeled data.
And very, very finally, there's a comment from Javier, which is, do you support SSML? I think SSML, you might be thinking about text to speech rather than speech to text. There's not typically a requirement for SSML in speech to text. But there is another question from Javier, which is a product question, really, which is, why do you have a base model and an enhanced model? What's the differences between those two things?
Sure. Simple answer is, what's more important to you, accuracy or cost? I mean, from a product perspective, that's the question. Our enhanced model is better. It has better accuracy. Downside is a little bit more computationally intense, and so we need to up the cost a little to cover it. So these are just two offerings that are available depending on your use cases. Try the base model because it's cheaper, and see if it hits your word error rate and business thresholds. If not, use our enhanced model. It's not that much more, and it gets you a little bit of a kick in accuracy.
Cool. Wicked. Well, Adam, this has been absolutely fantastic. Thank you so much for spending the time with us. I always do this. When it comes to speech recognition, it's a kind of a passion of mine. I always feel as though I learn a whole lot when I speak to people like yourself. So thank you for spending the time with us. Thank you, boys and girls, for joining us. And definitely, without a shadow of a doubt, you can see the name Deepgram there if you're watching this. Deepgram.com is where you need to go to check out all of the things that Deepgram do. Try the models, try the APIs, give it a shot. And yeah, definitely for your next speech recognition project that you've got a need for, check out Deepgram. Adam, is there anything else that you would add to that? Any other resources or places that you would point people?
Nope, deepgram.com and our developers.deepgram.com is for all of our developer resources, but your links from the homepage. Just start at the homepage, you'll find everything. Thank you so much, Ken. It's been a real pleasure.
Nice one. Thank you very much, Adam. And thank you all for attending. And we will see you at the next one. Thanks very much.